Gaining knowledge from empirical research requires understanding the results, but the statistical tests and annotation can be very overwhelming. In this section, we'll talk about strategies to avoid being too overwhelmed. Given what you've learned about APA style, where would you expect to find the summary of the results without the specific statistical information? The methods, results, introduction, or the discussion? As we mentioned in previous sections, the findings may be included in the abstract. They'll also be summarized in the discussion, and that might include additional details. The results section will obviously include the details of the specific statistical analysis and results, but the summary and the discussion can be a little easier to understand. The results section provides a lot of information in identifying specific statistical analysis and providing the results of those analyses. Gaining knowledge from that information requires understanding what the analyses and the results are telling us. A thorough understanding of statistics provides great insights, but it takes some time. For now, we'll focus on a few key ideas so that you understand why the authors summarize the results the way they do, so that you're actually gaining knowledge rather than just copying what the authors say. Descriptive statistics are an important first step. The measures of central tendency and variation provide insights about our sample. The concept of generalizability reminds us, though, that we're not just interested in our sample. We would like to learn about our population. Descriptive statistics are the first step in that process as well. Inferential statistics allow us to make inferences based on the data from our sample. These analyses use the descriptive statistics and other computations to determine the meaning of data, given what experts know about probability. That's a mouthful, huh? The important idea right now is that inferential statistics are based on probability. The likelihood of finding is due to chance, rather than being due to a systematic variation in our data. The p-value, also referred to as the significance level, represents the likelihood that the findings are due to chance. We typically use 0.05 as the magical value. A p-value of 0.05 would be interpreted as meaning that our findings would happen due to chance, without any meaningful relationships or patterns, 5% of the time. When the p-value is 0.05 or less, we say that the findings are significant and interpret them as meaning we have identified a meaningful pattern in the variables. The tricky thing is that we can have a statistically significant result that doesn't really mean anything. In the language of statistics, they have a low effect size. Here's an analogy that might help. With many scratch-off lottery tickets, you scratch in a certain place to reveal your numbers. Then you scratch another place to see if any of the other numbers match your numbers, or if you have the special symbol that means you won 10 times that prize value. So you could scratch all of the numbers and not match anything, or even have that special symbol. That would be like having a p-value greater than 0.05. You could scratch and find a match for your numbers. Then we get a little excited, right? Quick, scratch off the prize. Oh, it's a free ticket. That'd be like having a low effect size. If we had the special symbol and won 10 free tickets, that might be like a little higher effect size. At least we won something more than the money we spent. What we're really hoping for, though, is the special symbol and a large cash prize. That's like having a high effect size. These four concepts, descriptive statistics, inferential statistics, statistical significance, and the effect size, are just a starting point for understanding statistics, but they're a good starting point. Understanding the difference between descriptive statistics and inferential statistics reminds us that our purpose is to understand a larger group, and those with expert knowledge in statistics know how to use the smaller group to understand the larger group. Understanding what it means when a result is statistically significant reminds us that we're drawing conclusions based on probability, or the mathematical likelihood of something happening. Finally, understanding effect size helps us understand whether the finding is really meaningful. Taken together, this helps us understand the goals of the analysis, the underlying logic, and the meaning of the findings. We will talk more about statistical analysis as we carry out our project, but for now I want to focus on the big ideas represented in the last few slides. Those ideas help us understand where the results come from. That understanding, coupled with the expectation that the peer review process would not allow for inappropriate analysis, can help us understand the articles without getting into the details of the analysis. In other words, it allows us to be comfortable with the knowledge without getting overwhelmed with the information. We can do that using two strategies: reviewing the discussion section and using keyword searches in electronic files.